Hey GED students, I am super excited about this one because it's going to help prep you for one of the most challenging solving equation problems that could show up on your GED. Let's take a look. It says each equation below has been solved incorrectly. Somebody already did the work for you, but sorry, you can't copy them. They got it wrong. Find the error in the solution. So that's the first thing we need to do, find the error. Then find the correct solution. Find the correct solution just means the same as solve the equation. Now, why do I say this is prepping you for one of the hardest GED problems? Well, there's some tricky ones that sometimes come up where instead of asking you to solve them, they show you somebody else's solution and you have to find what line they made a mistake in. So this is pretty tricky. Okay. And a lot of times what I say to students is the best way for most of us to do it is actually to solve it ourselves and then see what we would have done. So I'm just going to go ahead and I'm going to just copy down this first equation, 9g plus 18 equals 45. And I'm going to think about if I was trying to solve this, if I was trying to get G alone so that I knew what he was equal to, okay, I would have to get rid of a couple of numbers, right? You can see here that G is not alone right now. I have a 9 and I have an 18 hanging out, okay? And we said whenever we have more than one number to get rid of here when we're solving, we are going to use the order of operations, but since we're solving, we're doing the opposite. We're getting rid of things. Even the order of operations moves backwards. Okay, so we should get rid of anything adding or subtracting first. So my first step, if I were going to solve this, would be to subtract 18. So let's subtract 18 here. Opposite of adding 18 is subtracting 18. Now I can do whatever I want to an equation as long as I do it to both sides. Okay, and then let's look at what we would get here. Okay, so if I were to make that change to both sides, the exact same change, I would get an equivalent equation, an equation that basically means the same thing, but here 8 plus 18 and minus 18 would be opposites, so I'd get 9g, and 45 minus 18 would give me, I'm feeling tired today, a little brain fried. Let's do it in our calculator. I suggest you do too, you guys. When you're thinking really hard about algebra, you can make dumb mistakes in adding. I've seen students be like, 1 plus 1 is 11. And I'm like, whoa, 5 minutes ago, you knew 1 plus 1 was 2, but you were just thinking so hard about algebra, you brain fried. Okay, so just use your calculator when you can. Okay, now, just in doing that one step, I already see somewhere where I went really different from this student. Now, that doesn't mean necessarily that that student's wrong. Sometimes there's more than one way to do something, but it did set up a red flag for me. I subtracted 18 first, and let's look at what this student did. This student chose to divide by 9 first. Now, first instinct would tell you that's probably wrong because Kate said that I have to do the order of operations backwards when I'm solving. And this student tried to take away the number that was multiplying before they tried to take away the number that was adding or subtracting. And you're right, they made an unwise move, which is why they went wrong here. But I mean, I could have divided by 9 on both sides if I wanted to, because literally you can do whatever you want to an equation. But what this student made this mistake because they didn't really understand about the way multiplication and division works. If they really wanted to divide by 9, they would have had to divide this whole side by 9. It gets a little messy. It's hard to remember. And so that's why I say just follow that wisdom principle of getting rid of things in opposite order, and then you won't get fooled, tricked by things like this, okay? So again, all I'm trying to say, let that kind of just wash over you because you don't have to have it memorized, okay? All I'm trying to say is that it's not that they can't divide by 9. It's just that it wasn't a wise move and it caused them to make a mistake they didn't even understand about, okay? And so I'm going to say that their mistake was dividing by 9 improperly. And that could have been avoided by following that order of operations backwards by moving anything adding or subtracting first. So what would we have moved first? We would have moved the plus 18 first. So we would have subtracted. Opposite of plus is subtract. So they could have avoided that by subtracting 18 from both sides first. Okay, awesome. Ooh, little tricky. So we did say, though, that we were going to find the correct solution. So we did half our work, but we don't have a solution yet. I have 9G equals 27, but that's not a solution because I don't know what G is. I don't know what G equals. I'm not going to know what G equals until I get G alone on his side of the equation. So I still have to get rid of that 9. Now's the time to divide. After I subtracted 18 from both sides, if I do divide by 9, you're going to see that I get a different solution here than our student got, which was what? Negative 13 they got. Okay, and let's see. Multiplying and dividing by 9 is opposite, and so it'll cancel out. G will be by itself. I'll just have one G, right? A single G. And then 27 divided by 9. Again, do it in your calculator, guys. Do it in your calculator later. You're going to be thinking so hard about other things. But I can see here my correct solution for this first one is G equals 3. Okay, so 2 parts to this. Tell me what they did wrong, and then tell me what the correct solution is. Whew, okay, that was a lot. Let's try the second one. Okay, next one. 11 equals 2K plus 25. And oh, right away I see what this student did wrong, but that's because I see so many students do this. Look at what this student's first move was. They were like, oh, I'll start moving numbers around. I'm going to subtract 11 from both sides. This is such a common error. Students kind of go into autopilot, but remember your goal when you're solving. So if you struggle with this, I'm going to put this little line through the equal sign so you can tell the difference between the left-hand side and the right-hand side. Your goal is to, on the side where K is, so there's K, get K alone. I want K to be by itself. Well, what numbers are over with K? Not 11. 11's on the other side. The numbers with K are 2 and 25. Those are the ones you should be moving. Leave 11 alone. 11's already where you want it. Okay, but of 2 and 25, which one should we get rid of first? Well, again, if we're getting rid of math, we're isolating the variable. We're moving across an equal sign. We go backwards. So let's move anything adding or subtracting first. So 25 is adding with that K, and so I'll do the opposite. I'll subtract. You say, can I do that? Well, you sure can, as long as you do it to both sides. Okay, so 11 minus 25, do it in your calculator. Please, 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 please. This is one of those times where students want to do it themselves and you guys make sign errors because you're not super familiar with negative numbers. And you're like, Kate, because you won't teach me. And I'm like, that's because we need to focus on algebra. Okay, but 11 minus 25 gives us negative 14. Your calculator can tell you that. And that would be equal to, well, adding 25 and subtracting 25 cancel, leaving me with 2K. And I seem to be moving on to the second step, the solving, and doing that first. But we'll write down, we already saw what the answer was, but we'll describe it in words in just a second. Let me finish up what I'm doing here. So what am I doing? I'm trying to get K alone so I know what he's equal to. Right now K is almost alone, but I can see there's this 2 hanging out. Okay, it's the 2 that's over there with K, not the negative 14. So it's the 2 I need to get rid of. And in order to get rid of something, you have to ask yourself, what is it doing? What is the 2 doing with the K? Well, they're shoved together. That means they're multiplying. So I'll do the opposite of multiplying. I'll divide with that 2. You say, can I do that? You can do whatever you want, as long as you keep your balance, doing it to both sides of the equation here. And now I kind of ran out of room, so I'm going to move to the right. Don't panic. But let's take a look at what would be on the left-hand side of my new equation. Negative 14 divided by 2 would give me 7, and that's going to be equal to whatever I get on the right-hand side of my equation. Well, multiplying by 2 and dividing by 2 cancel, giving me 7 equals K. I'm looking at it and I'm like, how'd I get the same answer as the student who was wrong? I didn't. You guys see where I went wrong? Holy moly, that was a dead silence for a while. I hope you see where I went wrong. I did exactly what I told you guys not to do. What? How silly. I made a dumb mistake because I was so focused on the algebra. That wasn't 14 divided by 2. That was negative 14 divided by 2. I'll do it in my calculator since I'm struggling so much. Hey, there we go. Negative 7 equals K is the actual solution. So what did this student do wrong here? Well, really, I mean, if you want to, you could subtract 11 from both sides. It's just like on the last problem. If I wanted to, I could divide by 9 on both sides. But it wouldn't be a super great move in this case. Because look what would actually happen if I divided by 11 or if I subtracted 11 with both of these. 11 minus 11, guys, that's 0. That's 0 on the left-hand side. And then your equal sign, it stays steady. It doesn't move. So I would have 0 equal to something. And what would I have 0 equal to? Well, I have still the 2K I haven't touched. So 0 would be equal to 2K. 2K what? Well, you just did something weird. You just did 25 minus 11. So 25 minus 11 is what? Like positive 14? Yeah, you could subtract 11 from both sides, but it didn't get rid of anything. It didn't make anything easier. It's just a weird equation. Okay, so I think this student's common issue, the real problem that they had is instead of moving numbers away from K, they started moving numbers towards K. Okay, so let's see. Let's just say they weren't isolating the variable when they subtracted 11. And there's lots of ways you could say this. Okay, guys, and once again, the GED is not going to ask you to write an essay like I am doing right here. So you say, why do you make me do this? Okay, it's because I want you to have those reasoning skills. So when we talk about it, when we look at it, you know what you're looking at. Okay, so they weren't isolating the variable when they subtracted 11. They got all in a muddle because of that. Woo, woo, woo. Okay, one more. We can do this. Let's see. T over 3 plus 6 equals 7. Now, this is one of those ones I always scold you guys for your math grammar all the time. My students are like, really, Kate? Why are you so anal? Well, take a look here. What this student did was times by 3. And they put times by 3 down there on the bottom. And they said, well, I want to times both sides by 3 because T is dividing by 3. And again, I would say, like, it's not the wisest first move. It's not what I would do first. But I mean, legit, you could if you wanted to, because you can do the same thing to both sides. But what this student didn't realize is when you multiply the entire left-hand side by 3. So if I wanted to times by 3, I would have to take the entire left-hand side and times by 3. That's a trickier thing than what they did. They just treated it like it was this little piece, T over 3 timesing by 3, not like it was the entire left-hand side. And so, you know, yeah, you could times by 3, but guys, let's just follow that lovely little wisdom principle that Kate asked you to follow so that things get cleaner, faster, and you solve with this wisdom principle of when I'm getting rid of math, I move the order of operations backwards. And you'll avoid getting trapped by things you don't understand, just like on this one, okay? And so that means let's move anything that's adding or subtracting first. Okay, so instead of getting rid of the divide by 3, can we get rid of the plus 6 first? Let's try it. Okay, so T over 3 plus 6 equals 7 was my original equation. And I will, when solving, get rid of anything adding or subtracting first by using opposites. And things will get prettier, faster, and I'll make less silly errors. Okay, so adding 6 and subtracting 6 really does zero out. And so all I'm left with is t over 3. And that's equal to, well, what is 7 minus 6? Just 1. Now this looks a lot nicer. I have t over 3 equals 1. And I want to get t by itself, so I want to get rid of this 3. And I have to ask myself, what is this 3 doing with t? Well, if it's on the bottom of a fraction, it's dividing t, and so I'll do the opposite. And look at me using those parentheses. I'm going to take the entire left-hand side and multiply by 3. But now, since I got rid of the 6, the entire left-hand side, oh, that's a lot easier. That's a lot simpler, okay? And now, of course, I can do whatever I want as long as I do it to both sides. Okay, so I'm multiplying the entire left-hand side by 3 and the entire right-hand side by 3. And if I get rid of that number that's adding or subtracting first, the entire side is a lot easier to deal with. Okay, so multiplying and dividing by 3 are opposites. They'll cancel. So in my new equation, what will I have on the left-hand side? Just that t. And that'll be equal to whatever I get on the right-hand side. And there's the math I said I was going to do. Careful, it's not 1 plus 3, it's 1 times 3. And again, when you're brain fried, sometimes you might even just want to type that in the calculator so you don't do something silly like write 4. But I see that the correct solution for this guy is 3. So what did this student do wrong here? You know, I'm just going to say they didn't follow my wisdom principle. You know, if they had gotten rid of the terms first, that's the numbers adding or subtracting. Okay, they wouldn't have made an error when they multiplied. Okay, again, you could phrase it differently. You could say they used the times sign instead of the parentheses, so they went wrong that way. That's another way to say what happened here. I'm not too particular about it. The GED is not going to have you write an essay, but it's important that we just see where the error was. So they wouldn't have made an error multiplying. Nice. Woo! Hard work. I'm a jerk. So good news if you're mad at me, guys. Really, at this point, all you need to be able to do is solve the equations. But I chose these 3 particular student errors to look at because, guys, those are the ones you make. You forget to work backwards when you are solving, or you just automatically assume that whatever's on the left moves right instead of examining where the letter is and moving things away from the letter, moving the numbers away from the letters. So those are probably the 2 most common errors for new students solving equations. All right, I'm mean. If you have any questions about this, be sure to post them to the Facebook group. I think you probably might have a few. All right, you guys, happy learning.